So I think that we're going to start now. So first of all, thank you everyone for joining this webinar. My name is Wohlschlegel, and I'm the Technical Services Manager in Allinea. My objective today is to introduce to you Allinea Forge, which is available on the CSCS systems, and I would like to help you get started, make sure that you know all the keys to use the debugging capabilities of the tools on your cluster. So if at any stage you have a question, please do not hesitate to ask in the chat window. You can probably find GJP in the list of the attendees, so feel free to direct the questions directly to him or to everyone. We will take all the questions, answer them one by one. So please do not hesitate if you want to interrupt or if you want to say anything. If you would like to talk, there's no problem. Please just don't hesitate to unmute your microphone, and we will be able to answer immediately. So anyway, without further ado, let's get started. So the agenda for this presentation is first of all to make a very quick, very brief introduction about Allinea and about the tools. You may be aware of our company, but just for the people who are discovering our tools and what we do, just wanted to make a very quick introduction. The objective of this presentation is really to show you Allinea Forge, Allinea DDT, and how to make it work on the CSCS systems and PizDaint. So it's meant to be interactive. We will have a live demonstration. I will show you different startup mechanisms, all of which are accessible to you. So first of all, I would like to make a small introduction about the HPC market. And what we see is that when we're looking at what people want, what people expect from HPC systems, it really can be divided into three major parts. So first of all, it's about scalability, because if the application can scale, then it means that scientists and users can resolve groundbreaking problems, can resolve complex issues, scientific issues, in order to get more resource, to generate more paper. But more importantly, even if an application is scalable, we want it to run efficiently, because the more jobs you run, well, the more scientific results you generate, which is always good. And the other aspect which is critical is about simplicity. We want the tools, we want the applications to be as easy as possible, to run as quickly as possible, so you don't have to worry about the problems, computing problems that may arise. But in any case, we are aware that sometimes there can be issues, sometimes the codes can crash. So in which case, we want to help people resolve these problems as fast as possible. So this is what we do. This is why we were created 10 years ago, and we developed two products. First of one is Allinea Forge, which is for the development community in the HPC market. And this target for this tool is to really help people reach high performance debug applications as easily as possible. The second product we have is called Allinea Performance Reports, which is here to help at a different stage, which is more towards production, when the systems are used to run applications. And here we want to help you run as efficiently as possible in order to maximize the productivity of your CPU hours. Now, CSCS has acquired Allinea DDT, which is part of Allinea Forge. So Allinea Forge includes both debugging capabilities and profiling capabilities, and it is meant to save time to people who are trying to develop new codes. So this toolkit is very accessible, and you're going to see in a few minutes that it's very, very simple to start a job with the debugger. It brings a lot of core features such as memory debugging and a lot more, and it's very innovative. So it is supported on the latest systems, including the CRAY machines, such as the machines you have in CSCS. So in terms of licenses that are available to you, you have at the moment an Allinea DDT license, which is fairly big. It's 65,000 processes, and it includes GPUs. And this means that with this license, you can run an application running on 65,000 MPI processes. We do not count the threads. So if you're using hybrid applications, well, you can debug the MPI procs, the threads, but also the accelerators that are running in the system. This license is floating, which means that you can use it on the CRAY clusters, but you can also use it on your laptop. So if you want to run an application locally on your laptop, provided it is Linux and Intel-based, then there's no problem. You can do so very easily. So as part of this license, you have access to debugging capabilities with Allinea DDT. So this is the full features. And you also have access to profiling capabilities in Allinea Map. So this is a trial license, which means that you can profile the first 30 seconds of your applications with the tool. So in any case, I wanted to mention this because this is critical, as Allinea Forge gives you both debugging and profiling within one interface. So this may be useful for you. Please don't hesitate to try Allinea Map if you have the time and if you want to see how it works. So in terms of technical assistance, of course, we are present. So you can go on the CSCS website. There's a web page dedicated to Allinea DDT. You can go to Allinea website if you want to see a bit more about what Allinea DDT can do and what is available. You can ask us for help. So Jean-Guillaume would be very happy to take any questions that you may have. Allinea is here to help you, so please do not hesitate. And if you want to deep dive into a specific topic, so at the moment we are running this webinar series, but if you want trainings and workshops, or if you want video about something, we are happy to oblige, and we will work with you to make this available. So if there is no question at this stage, I cannot see anything in the chat, so I would suggest that we get started straight away. So for the demonstration, what I would like to show you is, first of all, interactive debugging. So we'll show you how to use the Allinea remote client, how to submit jobs to the queue, how to make this work. We will have a look at the graphical interface of Allinea DDT, and we will have a look at the offline mode, which is running Allinea DDT without any graphical interface in the background. So again, at any stage, if you have questions, please feel free to ask. So first of all, I'm going to show you how to get started with the viewing. So the first step is to go to our website, so www.allinea.com. You go to the download page and you can retrieve the Allinea remote client. So this is a tool available on Windows, Linux, Mac systems, and you can open this on your laptop. So as you can see, I have started the remote client on my Windows machine, and basically I cannot debug on Windows, so all the menus are grayed out. But what I can do is connect to a remote system, and let's choose one. Let's choose the CSCS system. So if you want to connect to a remote system, you go to the remote launch menu, you choose configure, and you can create some entries here. And for instance, I've created an entry called CSCS PW, that's my name, on date. And I've configured a connection with two different hops. So the first hop is to connect on ELA, which is your front-end node. The second hop is for date. So basically, it's as if I was doing SSH on ELA, then SSH on date. So this can be configured directly in PuTTY, or if you have a .ssh config file, you can also create keywords. So this is why you can see here I'm using a connection called CSCS-ELA-PW. This is directly configured in my SSH entries. The next step is to specify the location of the tools on the system. So in your case, it's /apps common DDT. And once you've done this, so there's nothing else to do. You click on OK. You close this, and you can directly choose when you want to connect this new entry in the menu. So you will be asked for a password, so which is your SSH password, or if you have keys, this won't be the case. So when I enter this password, so the connection is going to be established, and all the menus in the graphical interface will be made available. So this is what you do on one hand. On the other hand, what you want to do is open the terminal. So with your favorite terminal, in my case is PizDaint, I'm connected to the system, and as you can see, I am in a working directory where I have a few jobs, a few submission scripts, so the everyday life. So what I want to do now is to modify my submission script to work with Allinea DDT. So what you do is, inside your submission script, just removing the colors, you will have, at some point in this script, an aprun command. Okay, so this is what you use every day to submit your jobs on the cluster. In order to start a debugging session with the interactive mode, so after you've started the remote client and you've connected to the system, all you need to do is to add the DDT-connect in front of this aprun command. That's all you need to do. There's nothing else to do. Once you've done this, well, you can save the script, you submit the whole thing, and the job will start. So what I will do now, I will give the screen to Jean-Guillaume, who will be able to demonstrate this. At the moment I'm in Japan, so the connection is a bit slow, which is why I asked Jean-Guillaume to show you in practice on his environment how this is working. So Jean-Guillaume, this is over to you. If you could just share your screen. Okay. So it looks like it's all well and good. So again, if you have any question, please don't hesitate to ask. So as you can see on the script, so Jean-Guillaume has compiled his code with the -G. He's connected the remote client on his Mac system. And okay, so the code is compiled. So yes, you want to compile the code with debugging symbols to ensure that you can see the variables, the lines, etc. So it's going to show this right now. So you want to interrupt this and make debug equal 1. Yes. So you want the -G. You preferably also want the O0 option, because in some cases, if you're using optimization, then the compiler may add inlining, may hide some variables, which may be a bit more complex to understand for beginners. So once this is done, so you submit the job with the DDT-connect. And once the job goes to the queue, so on the compute nodes, you will see a connection request coming up in your graphical interface. So this is perfectly normal. All you need to do is click on accept the connection request, and you will land on the run dialog, which will basically show you different menus such as memory debugging, GPU debugging, OpenMP, all these kind of things. So for this particular example, the application is just a matrix multiplication example, so it's very simple, pure MPI. So what we're going to do is just run this code, and if you click on this run button, you will see the job starting interactively on the machine. Okay. So it takes a few seconds. So again, Allinea DDT is scalable. You have a very big license. So here we are running on just 8 processes, but if you want, you can run on a much larger scale. That's not a problem, so please feel free to do so. So just to introduce quickly the graphical interface of Allinea DDT, you can see on top of the graphical interface several buttons, such as play the code, if you want to execute the application. You have steps button, pause, add breakpoints. All these different menus are available for you to control the execution. And basically, from there, you will control all the processes or threads in your application, which will be very good if you want to debug your application. So on the right-hand side, you can see that you have several files available. These are the files sorry, on the left-hand side, these are the files available in your project. So in our case, the core file here is the unmult1.c, which is where your application is. So you will have the different functions which are indexed, which helps the user to browse through the code, meaning that if you're looking for something, you can just click on these functions and you will automatically go to the right file, to the right function in the source code. So the source code is in the middle. And basically, if you see a bug in this code, you can very simply edit it. So it's a code editor. So if you type some text, random text in there, you will be able to change the content of your file. So hello Jean-Guillaume. And on the right-hand side, you have variable. So these variables basically are showing you, so you have multiple things. You have the variables, its name. You also have the value, some sparklines that indicate how the variable is distributed across the processes. So you can see the variables on a specific line or in the whole context. So okay, so if you click on the picture, you can also have the details showing you what the variable is and how it is distributed across the processes. So you have the full visibility on your application. So keep in mind that the debugger is both an observational tool that you can use to find and to see how the code is executed, find the values, but it's also a tool that will force the errors. So if you have a problem in your application, so for instance here we're going to run the application and click on play. If there is a problem in the application, which is not the case here, so you will get an error message. So what I would suggest to do, Jean-Guillaume, if you go to the unmult function, maybe we can recompile the application. So here we will insert a random bug. So if you go to the int j thing, down this, okay, so if you do I++ instead of j++ at the end, we're breaking the code. So now you can do a Control S. So by doing Control S, you save the file. If you do, you can do a make in the terminal. You can also make the code directly inside Allinea DDT. So, okay. So the code is recompiled. If you restart the session, okay. So we will get the code to crash. So again, there are two ways of using the debugger. The first way is to observe data, observe variables. The second way is if there is a crash. So as you can see here, because we have inserted a bug in the program, you can see that there is a segmentation fault, and Allinea DDT has stopped the execution at the location of the bug. Okay, so from here you can pause the execution of the processes. You see the line that is highlighted, and from there you get all the information you need to understand what is going on. So if you look at the stack at the bottom of the screen, which is the tab in the middle, no, not this one, the stack, yes, that one. Okay, so you can see here the location of the processes. So this is showing you that the processes are all stuck on line 65. So if I read correctly, so basically this means that you have a problem in your program. Your DDT is able to show you the content of the variables, show you the location of the crash, and from there you have all the tools to understand what the problems are in order to resolve it. So the target of the debugger is really to save your time. So if you have a problem, you can resolve the bugs quicker. So if there is any question about the graphical interface, this is a very high-level introduction. There is much more to discover about Allinea DDT, including memory debugging and other things, so GPU debugging as well. So these are things that we will probably discuss in the different webinar. Okay. So We're going to end this session right now, and I'm going to discuss a few other